Hello and welcome to another exam paper walkthrough. Thank you very much for joining me. Today I'm doing a GCSE maths paper. What I've actually done is I've created an AQA pushing for a 5 paper. This is all of the most complicated paper 1 questions that students have found on the AQA spec so far. So I put it together into a question paper, and it really is just for those students that are sitting a foundation that are hoping to really smash a grade 5. This is in preparation for the June 25, although this realistically will be useful for any exam series. If you find it useful, please do subscribe if you like. And attached to the description to this video, you will be able to find a link to a Google Drive where you can download a copy of the paper. If you've not already done the paper, I would recommend have a go at the paper first or do it alongside the video just to get the most out of it. I'd also recommend some music on in the background. As I record these, I tend to have some music on in the background, although this video was done in a slightly different circumstances. I've actually done this in front of a live group of students. So if you hear some background noise, that's what that is. Right, okay, let's start the paper. So I'll start the paper. So question 1, Joe wants to bisect the angle BCD. He uses this method, use a pair of compass to draw arcs the same radius from B and D, draw a straight line to intersect the arc through C. Write down the error with his method. So his first step should be using a compass and drawing arcs onto line BC and CD. How I'm going to describe that is he should have started by drawing arcs. So how did I write it? He should have started by marking points on CB and CD an equal distance from C. So he should have started by drawing arcs it helps if I spell arcs right. Arcs on CB and CD an equal distance from C. What that would look like to do this correctly, you put your compass point at C and you would draw an arc onto there and onto there. Then from that, to complete the method, you put your compass point now on both of the arcs, keeping your compass arms the same distance. You would arc into the center, then you would join that up with a straight line. So that's what it should look like roughly. Obviously, I'm not drawing that particularly well. I can't really easily get a compass on here. Part B, Kay wants to show all the points 3 kilometers from point P. Here is her answer. What has she done wrong? So if we talk about roughly what she would need to have done, so if she wants to represent 3 kilometers, she needs an arc. She wants to cover the points that are 3 centimeters from P. So again, she would get her compass arms and set them at 3 centimeters, and she would draw a full circle around P. So her shape or her arc line, let me just, it should be a circle. It should be a circle. 3 centimeters. Radius center P. So again, what that would roughly look like, again, I'm drawing this freehand. Something along those lines. Here is a rectangle. Use a pair of compasses and a straight edge to construct one line of symmetry. Show your construction arcs. So this is asking, use a pair of compasses and a straight edge, construct one line of symmetry, show clearly your construction arcs. So the way that I'm going to do this is I'm going to I'm going to attempt to draw a line of symmetry, splitting the shape in half this way. It's not the only way. You could have done it in half this way. I'm going to do it this way though. So I'm going to imagine placing my compass here and drawing a circle. And I'm going to kind of approximate what that would look like, hopefully. So let's say it's going to look roughly like that. Don't necessarily need to have drawn the full circle. Going to make that a touch bigger actually. So provided my compass arm is bigger than half the distance between those two sides, that would be all right. So if you imagine that's going to be roughly my full circle drawn with a compass. Let me just even that out slightly. And then I'm going to do, keeping my compass arms exactly the same, I'm going to do the same from the opposite corner. And hopefully if I can pick that up. If I do the same from the opposite corner, where the two sets of compass lines cross is exactly halfway between the two distances. So then I would use a ruler to insert a straight line between those 2 points. Provided I've done that perfectly accurately, that will give me a line of symmetry between the two shapes. So that's the rough method I would use with the compass. So again, because I can't draw it, use a compass and a ruler here, I've just drawn a very rough version of it. Okay, question 2. Here are two triangles, P and Q. Here is a statement. A transformation that maps P onto Q is a reflection in the line X is equal to -1. Write down one criticism of the statement. Well, it is a reflection, and it does map P onto Q, but it's not reflected in the line X is equal to -1. The line X is equal to -1 would be that line there. So this is actually a reflection in the line Y is equal to -1. So one criticism of the statement, the reflection line is in the line. So the reflection is in the line Y is equal to -1. Okay, part B. Here are two shapes, C and D. Here is the statement. A transformation that maps C to D is a rotation through 90 degrees anti-clockwise. Write down one criticism of the statement. Technically speaking, it is correct. That is a rotation through 90 degrees anti-clockwise. The issue is what they've missed out is the point of rotation or the center of rotation. So the center of rotation is missing. So one criticism, the center of rotation is missing. Okay, and question 3. Here is a triangle on a grid. The triangle is reflected in the vertical line, in a vertical line. Two of the vertices of the rectangle are at 7, 3, 7, 7. What is the coordinate of the other vertex of the triangle? Vertex is a fancy name for corner. So if I plot the two that are, it would help if I did it in the right place. 7, 3 and 7, 7. So that kind of tells us that we're reflecting it in this line here. So the third point or third vertex is going to be 4 away from the mirror line, so it's going to be there. So the coordinate of that would be 10, 3. And then the second part, what is the equation of the line of reflection? So this line, I've kind of drawn it as a dotted line already. The line is x is equal to 6. X is equal to 6. And then for question 4, work out, giving your answer in standard form. So I'll write what I'm actually trying to do because this isn't written in the way that I would tend to view it. So I'm dividing two numbers in standard form. The way we can do this is we can split our number part and our index part separately. So we can view that as 2 divided by 8, the number part. And then because we're talking standard form, we put multiplication in, and then we put our powers of 10 part. 10 to the power 14 divided by 10 to the power 9. Right, so 2 divided by 8 is the same as a quarter, which is 0.25. And then 10 to the 14 divided by 10 to the 9, we subtract the powers. So that would become times 10 to the 5. And then when numbers are in standard form, that number isn't in standard form because the number part is less than 1. So we would then need to, I'll put it in an extra line than I would normally. If I were to describe that in standard form, it would be 2.5 times 10 to the minus 1 times by 10 to the minus 5 would give you the answer 2.5 times 10 to the 4. Okay, for part B, 6200.07 is equal to 6.2 times 10 to the C plus 7 times 10 to the D. Work out the values of C and D. So this number has been split into 2 parts then. It's been split into this part of 6200 and 0.07. And then if I convert these numbers into standard form, that would be 6.2 times 10 to the 3. And then the second part would be 7 times 10 to the minus 2. So that C would be equal to 3. D would be equal to minus 2. And then question 5. V is equal to K over H, where K is a constant. Which 2 statements are correct? Well, this is a standard way of saying that I would pronounce that as V is indirectly proportional to H, or inversely proportional to H. So V is inversely proportional to H. You can also argue that it would be V is directly proportional to 1 over H. So those are the 2 statements that you would tick. Those are the 2 statements that you would tick. So question 6, circle the value of X. So if I start with the ratio of 1, 2 to 2 to 3, and I want to get it into the form X to 1. So I eventually want a 1 on the right hand side. So I'm going to do this. I'm going to times both parts by 3 to start with. So that would give me 2. And then if I times a half by 3, it would be 3 over 2. And then again, I want it to be 1 on the right. So to get from there to there, I'd divide by 2. So if I divide this side by 2, I'd get 3 over 4. So my answer is 3 over 4. Okay, question 7. Shape A is a circle with a radius of root 17 over 2. Shape B is a sector of a circle with a radius of 5 centimeters. Which shape has the greatest area, A or B? You must show your working. So I'm going to start with A. So for shape A, I'll call it SA for shape A. The area is going to be equal to pi r squared. It's a non-calculator paper. So I'm doing pi times by root 17 over 2 squared. And then if I square root 17, that would give me 17. If I square 2, that would give me 4. So that's just going to be 17 over 4 pi. Now I'm going to move on to shape B. For shape B, the area is going to be equal to... so for shape B, I'm looking at the size of the angle out of 360 times by pi r squared. So in this case, 60 divided by 360 would be 1/6 times by pi times by 5 squared. So that's going to give me 25 over 6 pi. So I've got the area of the 2 shapes. I now need to compare them. Your method for comparing them is slightly up to you. Well, not slightly, is up to you. You could go decimal. I'm going to put them over the same denominator. So I'm going to put them over 12. So I'm going to get that one over 12, I would need to times by 3. 17 times by 3 is going to be 51. So that's 51 pi over 12. And then to get this one over 12, I'm going to be timesing by 2. So that would give me 50 over 12 pi. So shape A is going to be greater than shape B. So which one has greater area? Shape A. Right. Question 8. Write 27 times by 3 squared to the power 7 as a single power of 3. So the first thing I'm going to do is 27 is going to be 3 to the power 3. And then if I 3 to the power 2 to the power 4 is going to be 3 to the power 14. And then I'm going to add those powers together, so that's going to become 3 to the 17. Right, question 9 was generally done quite badly. The first part wasn't too bad. Students struggled with the second two parts though. On the grid, sorry, I've missed that. There is a triangle in the shape. There is a triangle on a square dotted grid. On the grid, show that you can make a parallelogram with two of these triangles. So the easiest one to draw here would technically be a rectangle, because a rectangle is a type of parallelogram. So it's not necessarily the most obvious though. If I give myself a bit more space, I am going to run out of space for this one. So that is the option that I would typically go for. Your other two options are you could have drawn it as that triangle plus that triangle. Your other option, and again, I haven't really got room for this. I could have drawn it as that would also be a parallelogram, joining them like that. But like I said, the most common and easiest one to do is to make it into a rectangle, because a rectangle is a type of parallelogram. But the other two are perfectly fine. For part B, on the grid, show that you can make a trapezium. So trapezium, three of these to make a trapezium. I thought the most easiest one is, in effect, you can add a triangle onto any one of those shapes. So I'm going to do it like this. Again, not the only option, but probably the most straightforward one. That would be fine. Trapezium just has to have one pair of parallel sides. In this case, I've got the top and the bottom that are parallel. Sorry, parallel. Not the only option, probably the most straightforward though. And then a rhombus, 4 equal sides. So 4 equal sides. The easiest way to view this is if I draw them there, and then there and there, that would be a rhombus. But again, it was part B and part C that most students struggled with. And then the final one I will do in this session, misspoke, well, not misspoke. I'm recording the video in front of a live group of students, so I'm doing it in sections. So for question 10, P and Q are points on a line. 3x plus 2y is equal to 6. Complete the coordinates of P and Q. So it says that x is equal to 0 there. So if you put x is equal to 0 into this equation, you get 2y is equal to 6. So if 2y is equal to 6, then y must be equal to 3. And then for the other part, you're told that y is equal to 0. So 3x is equal to 6. So x would be equal to 2. So that's your two coordinates. Draw the line from the values -3 to 3. So part A gives us a good start to this. We can plot these two coordinates on 0, 3 and 2, 0. And then we're after a straight line that just joins those up. I'm going to carry on that pattern. We've got a gradient of minus half, 2/3. So 2 down, 1 across, 2 across, 3 up, 2 across, 3 up. So that's going to be my line. Join it with a ruler. Obviously, as I'm doing it on screen, I can't really use a ruler. You should use a ruler though, but that's going to be your line. Okay, question 11, the range of a set of numbers is 15 and a quarter. The smallest number is 2 minus 2 and 7/8. Work out the largest number. Well, the range of a number is equal to the largest minus the smallest. So if we're saying then that's the range and that's the smallest value, we can say that 15, I'll do it the other way around actually. So the largest I'm going to call x for now. So the largest I'm going to call x. So I'm going to say x minus, and then that's a negative number, minus 2 and 7/8 is going to be equal to the range, which is 15 and a quarter. Minus a negative number becomes the same as plus in that number. So I'm going to say that x plus 2 and 7/8 has to be equal to 15 and a quarter. So I'm going to minus 2 and 7/8 from both sides. So x is going to be equal to 15 and a quarter minus 2 and 7/8. To subtract numbers, you need to have the fractions as the same denominator. So I'm going to convert that to being 2 over 8 minus 2 and 7/8. You could convert these to both being improper fractions and subtract them. However, what I'm going to say is that 15 minus 2 is going to be equal to 13. And I still need to work out 2 over 8 minus 7/8. Well, that would technically be a negative number. So 13 minus 5/8. And then 13 minus 5/8 is going to be 12 and 3/8. Okay, question 12. Emma tries to simplify CD times by 2. Her method is C times 2 is 2C, D times 2 is 2D, so 2C times 2D is 4CD. What is wrong with her method? She has multiplied by 2 twice. So she has multiplied by 2 twice. And we could say answer should be 2CD. Okay, question 13, solve. So if we're trying to solve this, we need to factorize it first of all. To factorize it, it needs to go into 2 brackets. Both brackets are going to start with an x to make the x squared, and then you're looking for 2 numbers that multiply together to make the back term, so minus 12, and that add together to make the middle term, minus 1. That tells you automatically 1 is negative and 1 is positive, and that the negative is 1 bigger than the positive. So we're looking at minus 4 and plus 3. That's factorized it. Now we need to solve it. For 2 things to multiply together to equal 0, one of them has to be equal to 0. So either x minus 4 is equal to 0, or x plus 3 is equal to 0. So that means that x is either equal to 4 or x is equal to minus 3. So those are your 2 answers. X is equal to 4 or x is equal to minus 3. Okay, question 14. The language of this question or the situation kind of confused a lot of students. So a fair dice has been rolled. Fair dice has 6 sides, numbered 1 to 6. After it is rolled, 5 of the numbers can be seen. Write down the probability that one of the numbers, that one of these 5 numbers is a 2. In effect, if you imagine it, the only condition where it wouldn't be a 2 is if 2 had landed face down. The probability of 2 landing face down is 1 out of 6. So the probability of it not being face down is 5 out of 6. Next bit, work out the greatest possible sum of the 5 numbers. So the greatest possible sum of the 5 numbers would be if 1 landed on the bottom. So you need to add together 2 plus 3 plus 4 plus 5 plus 6. And I missed out 5 there. 2 plus 3 plus 4 plus 5 plus 6. If we're adding these in pairs, it makes it slightly easier. Those pair add up to 8. Those pair add up to 8. So you're doing 8 plus 8 plus 4.
Okay.
which will give you 20. And then question 5. Again, this was one of the. This actually hit on my pushing for 9 paper as well. It was a crossover question, but it was done badly by students on foundation and on higher. Which airport was affected by fog on one of these days? So we're looking for the outlier. We would expect it to be the lowest one. So here we're going to go day 8. 8 is an outlier. So significantly lower than other values. Than the rest, I'm going to say. Than the rest. For part B, Kim used the data to predict how many planes will go through the airport in a year. In her method, she uses an estimate of 150 planes in each 4-hour period throughout the day, assumes the same numbers of planes each day. Work out her prediction. So, I first of all want to work out how many 4-hour periods there are in a 24-hour day. So 24 divided by 4. Once I've got that value, I want to times it by 150, number of planes. That'll be the number of planes in one day. How you build that up to 1 year is slightly up to you. I just times it by 365. Some people times it by 4 to say how many in a month, times that by 12. Some people times it by 7 and then times it by 52. I think that's probably that's the way I would consistently do this though. So 24 divided by 4 is going to give me 6. 6 times by 150 times by 365. 6 times by 150 would be 900. So I want to do 900 times by 365. To make that an easier multiplication for myself, I'm just going to treat it as 365 times by 9. So 9 times by 5 is going to be 45. 9 times by 6 is going to be 54. So 9 times by 6 is going to give me 54, plus the other 4 is going to be 58. And then 9 times by 3 is going to give me 27, plus the 5 is going to give me 32. So I'm going to go 3285. I missed off 2 zeros here, so I'll put them on here. And that's going to be my answer. Again, lots of different variations of that. You wouldn't have lost a mark if you'd have times by 364, the number of days in a leap year. You could have also built it up to a year by doing, instead of times by 365, times by 4, then times by 12. You could also have done it by times in by 7, then times in by 52. So working out weeks. And then question part C. This is an interesting one. A lot of students will drop marks on this one. You're given 2 criticisms of her method. So in fact, fewer planes land in the winter than in the summer, and fewer planes land at night than during the day. If we break them down one by one, fewer planes landing in the winter means her prediction is an underestimate. So fewer planes in winter means her estimate is because she did it in the winter, so that would mean that it would be an underestimate. The second part though, fewer planes land at night than during the day. That means that, so fewer planes at night. She did hers during the day, so that would mean that her estimate is an overestimate. And because of that, you're not given you're not given anything other than fewer planes land in winter than in the summer, which would mean that hers was an underestimate. Fewer planes land at night than during the day, which would mean that hers was an overestimate. So because there are two conditions there, and the first condition means that her estimate was under, the second one means that hers was over, it means that her prediction could be too high or too low. It's not enough information to say which, but because of the two conditions, it could be too high or too low. Okay. So question 16, two consecutive whole numbers are n and n plus 1. Simplify n minus open bracket n plus 1. So the negative here is going to act on both of these two terms. So that's going to be n minus 1. So they would cancel. So we've just got minus 1. For the second part, multiply out. So n times by n would give you n squared. And then n times by 1 would give you plus n. Part C, the two numbers are added together, show that the answer must be an odd number. So we're doing n plus 1. So that's going to give us 2n plus 1. And we know that anything times by 2 must be equal to an even number. So we're doing an even number plus 1, which must be an odd number. Because if you add 1 to any even number, you will get an odd number. Okay, question 17. Solid is in the shape of centimeter cubes. Here are the plan and side elevation and front elevation of the shape. Centimeter cubes are added to make this cuboid, so a 3 by 4 by 4. How many cubes need to be added? Okay, so the plan and the side. I'm going to first of all just think about this part to make this into a full kind of wall. So to make this into a full wall, I would need 1, 2, 3, 4, 5 extra cubes. That would give me a full kind of L shape because we've got the full front elevation here and we've got the side elevation here. To that though, I need to add an extra to make this block. And I want to kind of view it as this section here. So that would be a 2 by 3 by 4. 2 by 3 by 4, so 2 times 3 times 4, which is going to give me 24. So I need 24 to complete that, 5 to complete that, so I need a total of 24 plus 5, which would give me 29 extra blocks. Okay, question 18. In each box, write a fraction less than 1 to make the solution correct. So I want two numbers that will multiply together to make 3. So that's going to be 1 and 3. And I need two numbers that multiply together to make 10. So I'm going to go 2 and 5. And then I can't put 3 over 2 because that's 1.5, so bigger than 1. So I'm going to go 1 and 2, and I'm going to go 3 and 5. Other possibilities here, two numbers that multiply to make 10 could have been 10 and 1. So I could have had, could I make that work? I couldn't make that work. Because 1 over 1 is bigger than 1, and well, is not less than 1, it's equal to 1, and 3 over 1. So that's my only combination. Question 19. In each box, write a decimal less than 1 to make the calculation correct. So I need two numbers that multiply together to make 6 in effect. I'm going to go 2, so 0.2 and 0.3. And they would multiply together to make 0.06, 0.06. Other options, I could have had 0.1 and 0.6, that would work as well. Yeah, those are my options, I think. Okay, question 20. Sequence has 3 terms. The term rule is multiply by 8 and then add 11. The first term in the sequence is -1. Work out the third term. Okay, so if I go -1 times by 8 plus 11, That's going to give me minus 8 plus 11, so that would be equal to minus 3 for my second term. My third term then, minus 3 times by 8 plus 11 is going to give me minus 24 plus 11, which would give me minus 13. So minus 13. Part B, the order of the three terms is reversed to make a new sequence. Work out the term-to-term rule for this new sequence. So we just need to go the opposite of this. So multiply by 8 and then add 11 is going to become subtract 11. Subtract 11 and then divide by 8. Question 21 then. Three identical isosceles triangles are joined to make a trapezium. Each side has a base of b and a perpendicular height of h. Work out an expression in terms of b and h for the area of the trapezium. So the area of a trapezium is the area is equal to a half of a plus b, and those are the perpendicular sides, times by h. So for this one, that's going to be half of b plus 2b, so that's going to be half times by 3b times by h. So that's going to be 3 over 2 bh. Part B, this diagram shows the same trapezium. Work out an expression in terms of b for the perimeter of the trapezium. Okay, right. So I'm going to go for the perimeter first of all, all the way around the outside. So that's going to be 3b plus, so I'll say perimeter is equal to 3b plus 2s. And then we've got b to s, 2 to 3. So that means that 1b would be equal to 1.5s. So 2b would be equal to 3s. Sorry, 2s. So that means that s is 1.5b. So that's going to be 3b plus 1 times 2 times 1.5 is going to be 3b. So that's going to be 6b. So my expression is going to be 6b. Okay, question 22. Complete the table of values. So y is equal to x squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4. I'm going backwards. Minus 1 squared is 1, and minus 2 squared is 4. So plot that minus 2 and 4, minus 1 and 1, 0 and 0, 1 and 1, 2 and 4. We join them up with as smooth a curve as we can. So you'll wrist on the inside of the curve. Use your graph to estimate the value of the root of 2.7. So to find the root of 2.6, so we want 2.6 is going to be this line here. And we want the two values. So I'm looking at roughly 1 point. I've not drawn that particularly well, that line there. So let's just make it a little bit better. So I'm looking at roughly 1.6 and minus 1.6. So minus 1.6 and 1.6. Right, question 23. Circle the expression of the range of n consecutive integers. Well, the range of any consecutive integers are going to be the same as the range of the first consecutive integers. So if I imagine it's 1 and n, 1 being the first term, n being the last term, it's going to be n minus 1. Okay, question 24. Here is the graph of, use the graph to estimate the solutions of. Right, so it is the same equation, I was just double checking that. So we want to find where y is equal to 1. Y is equal to 1 is that line there. So we just need to read off those two values. And it looks pretty much like x is equal to 2.5. Or x is equal to 9.5. Or x is equal to 9.5. Okay, question 25. Use a ruler and compass in this question. So I can't really use a ruler and compass, so I'm going to just bring this into Word and help me out a little bit. Okay, so to do this, the tree is to be planted in the garden. The tree will be in the region that is closer to AB than BC. Label the region R where the tree could be planted. Show all your construction lines. So we want it to be closer to the line AB than it is to BC. So the first thing that we want to do is to do a perpendicular, not perpendicular, we want to do a bisector of the angle ABC. So to do that, we need to do from point B, we need to use a compass, and we only really need our full arc lines on. So I'll imagine, because I can't use a compass particularly, so if I've placed my compass point here and arced, it's really this arc and this arc that I'm particularly after. From there, I want to do the same an arc where the center of the circle would be at this arc line and this arc line. And I'm going to arc into the center. So again, if I imagine doing that, right. So roughly if I place this there, and then do the same from the other side, place that there. Where these two arc lines cross is really what I'm after, which is that part there. So where these two compass lines have double crossed, that becomes my point from my bisect of the angle. So I go from B through, try that again. So I'm going to go through B and then through my double arc and extend the line. Right. Technically, what I'm going to do is just change these colours, hopefully. Let's see if I can do that well. Right. Separately. Okay, question 26, write down the value of cos 90. Your method for this is slightly up to you. I always view it in terms of the two graphs. So sine starts at 0 and oscillates over a 360 pattern. And cos does the opposite. It starts at 1 and oscillates over the 360 pattern. So 0, 90, 180, 270. Those are the key ones really. So cos of 90 would be 0. There are other ways that you can remember it. The finger trick is quite a decent one. I always remember it by the pattern of the two graphs though. So I'll put that's the cos graph. Okay, question 27. Erica tries to sketch the graph of y is equal to 1 over x, where x is not equal to 0, and that's her attempt at the sketch. Make two criticisms of her sketch. Well, the first thing, this is a reciprocal graph, and a reciprocal graph has to follow this kind of pattern. And we have, so obviously this is our x, this is our y. And then we have this pattern where they can't touch the graphs. So the way I'm going to describe this is I'm actually going to split this into two parts. So I'm going to call this part 1. And I'm going to call this part 2. So that's roughly what part 1 should look like. So my first criticism is going to be, so part 1 is in the wrong. And part would be okay, is in the wrong place, but I'm going to call it quadrant because technically on a 4-part graph, there are 4 quadrants, so it's in the wrong quadrant. And then my second criticism is that this second part shouldn't touch the y-axis. So I'm going to say that part 2 shouldn't touch the y-axis. So part 2 should not touch the y-axis. Okay, question 28, circle the value of cos 90. So again, the cos 90 came on, and it was actually done twice, and it did badly in both parts. So we did the graph earlier, but this is the cos graph y, x, and it starts at 0, 90. So the value would be 0. Right, question 29. Use 8 kilometers per hour is equal to 6 miles per hour to convert 96 kilometers per hour to miles per hour. Okay, so I'm going to kind of do this with a very, very basic ratio table. So 8 kilometers is equal to 5 miles per hour, and I want 96 kilometers. I should have really put a colon there instead of an equals. So to get from there to there, I'm going to be timesing by 96 divided by 8 would be 12. So I'm timesing by 12. So I need to times by 12 there as well. So that means that I'm looking at 5 times by 12, 60. So 60 miles per hour. Okay, part B, x kilometers per hour is equal to y miles per hour. Use the fact that 8 kilometers per hour is equal to 5 miles per hour to write a formula for y in terms of x. So for y in terms of x means that we want it to be y equals. So I'm going to kind of carry on with this ratio version over here. If I say that x to y is 8 to 5, then it holds true then that x over 8 is going to be equal to y over 5. And then I actually want y, so I'm going to times by 5 on both sides. I'll kind of show that there. So I want to times by 5. So that would give me 5x over 8 is equal to y, which is what we were asked to show. So I'm going 5 over 8. Okay then, and question 30. Anna plays a game with an ordinary fair dice. If she rolls 1, she wins. If she rolls 2 or 3, she loses. If she rolls 4, 5, or 6, she rolls again. When she has to roll again, if she rolls an odd number, she wins. If she rolls an even number, she loses. Complete the tree diagram with the 4 missing probabilities. Okay, so we've got an ordinary dice. So the probability of rolling a 1 would be 1 out of 6. The probability of rolling a 2 or a 3 would be 2 out of 6 or 1 out of 3. And then, so the next one that we need to look at is if she rolls a 4, 5 or a 6, the probability of her then rolling an odd number is going to be a half, or 3/6, and the probability of rolling an even again would be a half. So that's my completed tree diagram. Right, part B. Is Anne more likely to win or lose? You must work out the probability that she wins. Okay, so let's work out the probability that she wins. So probability that she wins, I'm going to call PW. So probability that she wins is this branch, or let me just, it doesn't particularly matter, or this branch. And we need to add them together. So the probability that she wins is going to be 1/6. That's the probability that she rolls a 1 the first time, followed by the probability that she rolls a 4, 5 or a 6, followed by an odd number, which will be a half times by a half. So plus a half times by a half. So that's going to give us 1/6 plus 1/4. So if we want to add these together, we need them over the same denominator. So I'm going to make the denominators both 12 because that's the lowest common multiple of 6 and 4. So to do that, I need to times the first fraction by 2, so that's going to be 2/12. And I need to times the second fraction by 3, so that becomes 3/12. Which means the probability that she wins is going to be 5/12. So I can jump straight to that. However, it's a 4-mark question, so I'm going to do a little bit more, and I'm actually going to work out the probability that she loses 2 ways. This is just a good way to just check that we've got it right. So first of all, I'm going to say that the probability that she loses is going to be equal to, she can either win or lose, so it's going to be 1 minus 5/12. Which is going to be 7/12. So that's what we think it's going to be. I'm also going to check that by working it out a separate way. So method 1. And then just to confirm that, I'm going to work it out a different way. So the probability that she loses then is going to be equal to this branch followed by this branch. So that should be 1/3 plus a half times a half. So that's going to be equal to 1/3 plus 1/4. And then again, like we did it over on the last one, I'm going to put them over the same denominator, which is going to be 12s again. And I times the first fraction by 4, so that's going to be 4/12, and the second fraction by 3, so that's 3/12, which gives us again 7/12. So we're confident that the probability that she wins is 7/12 because I've done it 2 ways. Is Anna more likely to win or lose? So she's more likely to lose. So I'm going to finish that with more likely to lose. And that brings us to the end of the paper. Before I sign off, I'm going to bring up the rough marks, the rough grade boundaries, and the question level analysis just to discuss that briefly. Okay, so this is a breakdown of each of the questions, and you can kind of see how I've put this question together. So what I did was I arranged it by roughly order of difficulty, although that's not actually holding true. You can generally see how it did, although that Locus one has jumped in quite early for some reason. What I did was it does work. The color coding confused me for a second there. You can see that what I did was I picked the worst done questions, or the most complicated questions, and then arranged them by order of how questions found it. So the facility by grade. And for some reason, this 73.2 is green, and then the harder ones are green as well. Which isn't a particularly useful thing. The color coding threw me out completely there. So you can see that they range from 73.2 up to 9.22. which is the question facilitated by grade for students that were aiming for a grade 5. The rough grade boundaries for this, like I said, it was a pushing for a grade 5. So these questions were selected as the most complicated that students found all of the paper 1 questions in all of the exams that they've sat so far. So it's just a selection of the most complicated question. Because of that, it means that the grade boundaries are exceptionally low on this paper, because it is much harder than a typical foundation paper would be, because it is just for those students that are really pushing for a grade 5. Each of the topics will be covered in the chapter index to this video, just so you can get that good idea of it. The colour coding isn't particularly anything important to you. It was just, for example, the locus, there were parts A, B, I think there were A, B and C possibly. Let's have a quick look. There were part A and part B. So any question that was broken up into parts, what I did was I focused on the most complicated part, and that gave us our questions facilitated by grade. Thank you very much for joining me. I hope you found this video useful. If you have any questions, comments or feedback, please put them into the chat to the video and I'll get back to you fairly quickly. I'm fairly prompt with that. I hope the rest of your revision goes exceptionally well. I will be releasing some other predicted papers. If you've not already done those, check them out. You will find that easier to do if you've subscribed. If you give the video a like as well, it will make it more visible for other students. Good luck with the rest of your revision, and I hope to see you soon.